Welcome, Calculus BC. This is Lesson 2-1, Product, Quotient, and Trig Rules. Let's begin. So this is a bunch of review. Let's talk about the product rule. The product rule, when you are multiplying two functions together and you derive them, the derivative is f times g prime plus g times f prime. I don't like writing it that way. A lot of times I'll write it as f prime times g plus f times g prime. It's the same thing, but I like keeping my f's first and the g's. The book might do this to you. Any way works. The whole point is you're deriving one of the functions plus deriving the other function. All right? Quotient, another way of putting this, first times second. They wrote it as first times second prime plus second times first prime. Whatever, it's the same thing. Quotient rule. So you usually see it in this format when you're deriving a quotient, so a function divided by a function. Here's a format here, g times f prime minus f times g prime over g squared. Another notation for this, top and bottom. What I like doing is I like saying f prime times g minus f times g prime over g squared. Just like keeping my f's and g's consistent. It kind of matches what you see with the product rule. The only difference with the product rule is we're subtracting between the two on the quotient rule and we're adding here. So I kind of like keeping the format the same because this confuses me when you mix up the f and g primes. But whatever way you want to do it, I don't care. Let's do some practice. So I want to break down. Let's treat this as a product rule. So this is going to be my f function and g. So maybe as you're practicing this, you write out your f is 3x squared minus 2, and your g is going to be 2x plus 3. That would make my f prime 6x, and my g prime is going to be 2. So as I find, and it's kind of weird because it's function f of x and f's, but just deal with it. So you can go h and g if you want to. I'm going to say my f prime of x now equals f prime, so 6x times regular g, 2x plus 3, plus regular f, 3x squared minus 2, times g prime times 2. Let's clean that up a little bit. So if it's a test for your response, this is right, but sometimes we have to clean it up, especially if it's multiple choice. I'm going to distribute that 6x and get, not 8, 12x squared plus 18x. Distributing this 2 to both terms is going to be 6x squared minus 4. Combining your like terms, you're going to get your final answer. You got your 2x squareds, so 18x squared. And then plus 18x minus 4. So there is the correct answer. Let's try another one. This is going to be quotient rule because we see we're dividing. So this is your f and g. Your f is 2x squared minus 4x plus 3. Your g is 2 minus 3x. So my f prime would be 4x minus 4. And g prime is going to be negative 3. If I'm plugging in the formula, it's over there on the side, I'm going to say f prime, so y prime equals f prime, so 4x minus 4, times regular g, 2 minus 3x, minus regular f, 2x squared minus 4x plus 3, times g prime, negative 3, all over 2 minus 3x squared. Now sometimes you have to clean up the top. So what I'm going to do is this binomial, I'm going to FOIL it out. So it's going to be 4x times 2, or 8x. 4x times negative 3x is negative 12x squared. Negative 4 times 2 is negative 8. Negative 4 times negative 3x is positive 12x. So this minus negative 3 kind of combines to plus 3. Those will cancel out. So I'm going to distribute 3 to each of those. So it'll be plus 6x squared minus 12x plus 9 over the same thing. So 2 minus 3x squared. And then if I combine things in the top just to clean it up, x squared is going to be negative 6x squared. 12x, negative 12x, these cancel out. So I'm left with plus 8x from this guy. And then minus 8 and plus 9 combined to plus 1. All over 2 minus 3x squared. And that might be an answer if this was multiple choice that you would see as an option. All right, derivatives of trig functions. So just to review, derivative of sine is cosine. Derivative of cosine is negative sine of x. Derivative of tangent is going to be secant squared of x. So secant times secant. Secant is secant tangent. Cotangent is negative cosecant squared. Cosecant is negative cosecant cotangent. One thing I did with sine and cosine, we did this like circle. So derivative of sine of x kind of forms a circle, is cosine of x. And derivative of cosine was negative sine of x. And derivative of negative sine of x, if you follow those rules, is negative cosine of x. And derivative of negative cosine is sine. If you remember, you can go backwards for integrals. But that's one way I kind of remember that. So let's say I want to do this problem, y is sine of x over cosine of x, which you might know is the same thing as tangent. But let's say I don't know this rule. I want to use my quotient rule, and that's f and g. So my f prime would be cosine of x, and g prime would be negative sine of x. Using my quotient rule, I get y prime equals cosine of x times cosine of x minus regular f sine of x times negative sine of x all over cosine squared of x. Okay, so what you have on top is you have cosine squared of x plus sine squared of x, because negative negative sine squared, over cosine squared of x. Cosine squared plus sine squared, this is one of those rules that you should memorize. That equals 1. So this is actually just 1 over cosine squared of x, which is the same thing as secant squared of x. Secant's 1 over cosine, which is the rule. So it's nice that it works out. All right, that's it. Stop in there.